have seen the movie Entiran or Robot 2.0? Can I assume yes?
Yes.
In some language?
Yes.
Right?
Yes.
Okay. So, all of you agree both in 1.0 and 2.0? Second part is, was it something that's the actual answer I wanted? It was planted by a human. So, a lot of times we see a lot of horror stories that we're going to see a world where robots 2.0 like machines will come and take over our world. So that's, in one word, technically what I call as when it went bonkers. You try to put the switch off button or the control C. How many of you did that? Almost everyone, right? So humans have the control. You have the control C button, right? So that's the same thing that's going to happen in the case of so-called 2.0 or Entiran or it's Akshay Kumar or Rajnikant 2.0 or 3.0 may come. So given that prospect of AI, let me in the next 30 to 40 minutes demystify some of the issues with respect to why the sudden love for AI is its own nemesis, because people are unleashing systems without being tested. And we are the victims. We, by means of that, I mean anybody who is consuming an AI application today. So I have another quiz question here. Thing in Google to search, it reads before you can complete it, right? Much like your spouse, for those of you who are married, right? But think about it. What's that? It's about an AI at the back end. Now it's gone even further. Now, in my Gmail, it's not letting me complete my email. It even completes my email. Think about it. So Google is closer to me than my spouse. That's the reality. And reality is the algorithms inside Google and Facebook are running consumer behavioral algorithms which know you better than any of your best friend or your parent. So imagine when you get an ad in your Facebook, suddenly related to just 10 seconds back, you sent an email about some subject to some of your friend, and you have an ad very closely related to that topic popping up in your Facebook. What's that? That's AI. So there is a talk, I think sometime later during the day, I hope the gentleman will talk about the privacy issues. But let me talk about an overarching perspective of AI, because one thing, are you convinced? You're all already using AI. Are you convinced? Yes, right? So now that you're talking about an AI first world, there is another important element which is very, very, very critical from the perspective of software engineering. How many of you feel that a good amount of attention is being paid to software engineering, which we have paid attention to over the last 40 years, right? Over building web systems or mainframe systems or client-server systems. We had a very good discipline, right? We had good requirements, we had good architecture, good design, good unit testing after coding, then good design practices, good coding practices, good testing practices, integration testing, system testing, and finally user acceptance testing. We had a structured method. But the problem is the glamour of AI is such that people are shortcutting this cycle. And it is up to this room to make an awakening. Go back to your practitioners who are developing AI systems, who are asking you to go and release AI systems in the field. Go back and tell them, have you gone through the proper SDLC? So the facts which I'm going to tell you today are about the need for reinforcing the message that AI system is yet another IT system. It's not that when you talk about a glamorous new technology like AI, it's going to suddenly change the fundamentals overnight. It's about staying true to the fundamentals. When you stay true to the fundamentals, what do you guys testers feel about a normal IT system life cycle? Don't you feel testing is the one which is the most important and the largest percentage of time taking in the life cycle? Do you agree?
Yes.
Yes, right? So why should it not be the same for AI? That's what my conjecture is. So what I will do is I will go through literally a laundry list of the testing challenges, testing imperatives, and fortunately or unfortunately very few testing approaches, because it is yet to be discovered. It's an area which is being explored. We just started scratching the surface of how AI systems need to be tested, but it's a long way to go. But as more and more Gmails, more and more ad systems, more and more search engines, more and more Alexa or Google Nows or all of this become penetrate our lives, we will see the need to build SDLC into the entire end-to-end of AI systems as a basic requirement for us to stop questioning those who are releasing these untested systems onto us. Why? I'll give you at least two incidents. I'll start with one incident which happened very recently. Very sad, but happened. Amazon, one of the top R&D units investing millions or billions into AI, is replaced one of its HR functions with an AI bot. And unfortunately, it had to withdraw the bot within a few days because of its gender bias. It was biased against females. The way the algorithms were giving results was biased towards males. And that's not acceptable in a modern world of fair practices of employment. And guess what it had to do? It had to go back to roots, replace the HR system by its older human-driven system. So what's this? This is a classic example of not following the golden mantra of testing adequately. Did you test adequately for fairness? Did you test adequately for variety of inputs? Did you give completeness of your test inputs? I think the sole blame goes to the testing team of the HR bot, which did not do a full coverage analysis of the wide varieties of inputs that will go in, wide requirements from fairness perspective, and wide imperatives from the perspective of the legal implications of safety. So imagine that tomorrow we're going to get a driverless software out there and running the car for you. The implications. Today we shudder at the thought of giving, I don't know how many old parents are there, a 16-year-old daughter or son in the car, right? It's a standard nightmare of American parents. Indians, I think, still 18, right? So imagine that now we're going and giving it to a fairly unknown beast called an AI program. Imagine what you're trusting it with. It is you are trusting it with your life. So the second accident I'm going to tell you about is actually a loss of human life which happened in US. A driverless car could not react in time to a woman passing when she was carrying her cat or something. She was walking her I think pet dog or cat across the road, could not detect in time, could not stop, and unfortunately you had to lose a human life. So these are two extreme scenarios. One we had loss of life and the other which had unbiased environment. Endless results. Till now, lot of commercial AI deployments have not gone the way they're expected to. I'll give you the third incident. Microsoft about 4 or 5 months back launched for fun a chatbot for people to interact, right? And unfortunately, people misled it with a biased set of data, which was racially not acceptable. It was consisting of a lot of unacceptable lingo. And because of the language which is fed into it, it started spewing out unacceptable language. So Microsoft had to withdraw the bot. So imagine these three wide-ranging incidents of actual deployments of AI software onto us. And now think about what are the implications. All of these I can fairly and squarely put the blame on not having adequate testing being done on different aspects. I won't say it's purely functional, because the moment you talk about AI, there are new dimensions. We call it non-functional or what, I don't know, but I'm going to come to those elements. testing for explainability, testing for ethics. These become very important. Testing for the legal implications. Because the moment you bring a person out and put a bot or put an AI program, suddenly you're doing some small accident compared to bot software going into an accident. 16-year-old daughter or the bot? 16-year-old daughter, you forget, right? Because there's a human element there. But for an AI bot, the question comes, that's not enough. It goes back. Whom will you sue? The guy who wrote the software? Or the guy who fed the data to train the software? Or the company which released the software? Or the company which bought the software? Or the firmware company which actually bundled it into the hardware? Or the hardware company which bought the firmware? Whom will you blame? Whom will you blame? Don't know. It's a jungle out there. But at the same time, it is irreversible. We have to live with it because in yesterday's note or day before yesterday's note, Tesla has said that they are going to launch 1 million robo-taxis to counter Uber and Waymo. So imagine there will be fleets of driverless cars on US roads. Already they are there in Phoenix, but they're in many, many states and in many countries. And not only that, we're going to go further to driverless trucks, we're going further to driverless thoughts. In the simplest terms, Wikipedia says, a machine or a software or a hardware empowered with the software displaying intelligent behavior. What do you mean by intelligent behavior? Intelligent behavior could be multiple types. Let's say intelligent behavior is something which is able to sense like what we do, right? What are the senses we are capable of? We can see, we can hear, we can talk, we can write, we can speak. So one aspect of intelligence is about, can we mimic human senses? So today you have computer vision systems, natural language processing systems, speech understanding systems which are mimicking what humans do. So one aspect of human intelligence is about being able to mimic human senses. So that's where AI capability is there. The next important capability, which is very interesting from a human perspective, is we see a lot of information around there and we can make inference from there. For example, I can look around here, I can safely say there are more dark colored dresses as compared to light colored dresses in this room. What's that result of? I looked at the raw data, I created a pattern out of it, right? So what's that about? It's about intelligently abstracting generate pattern within a large amount of raw data. And believe me, that is the crux of AI today. That's what happens in automatic driverless car. It has seen many sceneries in life. It has been driven through many states, many traffic signals, many scenarios of traffic. It has been fed all that intelligence. It also knows what speed your neighboring cars are going. And then when you let go without any humans, it is able to understand at every moment. Every moment it's getting new input. Based on the digestion of the input, it's getting a new pattern. So artificial intelligence is about taking raw data and inferring patterns from it. That's a very crucial element of intelligence. So there are two elements of AI. One is mimicking human senses. Second is mimicking human responses. What is response? When you see a scenery around, which is the lanes of traffic going around, the response should be about what should be the braking speed, what should be the steering of the wheel, autonomous software which is being released out there to perform human-like tasks. Now, what are the challenges? Recently, there was a study done in the AI field, and believe me, these were the challenges which were talked about in the history. I've circled 3 important challenges. Testing is a big challenge in the context of AI systems. Because people feel that a lot of AI systems launch from the field with improper testing. Second is limited transparency. Transparency, when I say, we don't know what is the internal algorithm which is governing. Third, it says privacy and safety. So when I say that, one of the important things is, today we need to have all of these things rolled up into our testing process. What do you need when you do testing for AI systems? You need to test for explainability. Explainability means if which a doctor would otherwise take, I should be able to give similar explanation when I have an AI program to be sitting there. So explainability testing is a very important area. Security challenges. Today, because of the exposure of data to the computer vision, natural language, we are exposed to far greater variety and volume of data which we were not prepared for. In the conventional IT systems, when you had a functional program, you had very structured test cases. Now in the context of text, speech, image, video, test data itself is complex. And testing for all varieties of complex scenarios is even more challenging. Imagine a driverless car. Imagine all kinds of sceneries it has to go through. I'll give you one accident which happened in Bay Area. A Tesla car went and hit the back of a truck. Because spoofing small portions of an image, you can convert a cat to a dog. I'll show you examples. These are amazingly simple attacks which are possible on modern AI systems. With just some simple bits being changed. Need for automation. If you talk about today's data about driverless cars, talking of millions and millions of bytes. Can you do all of them in manual? You have to develop automated systems which can test end-to-end AI systems. Precise notion of verification and validation very difficult in AI because AI is approximate science. AI is not a mathematical equation or an engineering specification. In AI, we always deal with what is known as probability. There is never a perfect solution for a particular problem. We always talk about the best possible solution. So you can always be having certain sense of doubt that there may be a better solution than what I have proposed now. If you do an engineering solution, what do? I give an engineering drawing to my architect, he builds a building, I can go and verify if there is even a slight small 1 centimeter deviation in the building. But in AI, we don't have the rigid specification. So that's why there is no test oracle possible in AI. And that's a huge challenge. When you can't have a test oracle, you have to invent around for testing AI systems. Ethics in AI are getting more and more important because we're talking about replacing humans with AI systems. In view of this, I'm exposed to it. So unless otherwise specified, 99% of the systems of AI today are of this type, where AI is an API invoked by an end-to-end AI system. So AI systems use standard testing systems which you do on a web-based system or integration systems. All of that hold true in AI systems also. So if you see AI-powered systems, in AI-powered systems we evaluate multiple algorithms for the same data to evaluate what model is the best. And then itself comes the first challenge of AI. What is the notion of which is the better model compared to the other? So here is where we always stop at some model saying that okay, I'll compare 10 models, I've taken the best model out. But there will always be a question. Is there some extra effort I could have put at trying to get a better model? And the answer is yes. Because ultimately, AI is an optimized problem. AI is not a fixed problem. Out of hundreds of possible solutions, you take out one model from the large data and say, okay, this is the best possible explanation of all this raw data. So in modern AI systems, testing is ultimately about verifying whether what you have chosen as the final program is optimal or not. But then, there are other issues with respect to verification validation. One of the other things which is basically useful for us to understand is you cannot always have a formal test oracle which says that this is the gold standard which is verified to be functionally correct or not. Because ultimately you're choosing one possible best algorithm out of all the possible algorithms and you're choosing one, right? So all you can do is, this is approximately correct. So complete functional testing in terms of correctness of the program is impossible. So what you do is you approximate functional correctness by increasing the accuracy of the model you test and say that out of all my possible models, this is the most accurate. And then the next possible challenge is, which is very important. Today the most powerful workhorse of AI is what is known as deep learning. Deep learning is basically a simulation of human brain in form of something called as a neural net. And the way they work is, they work out structure which is very similar to human brain, and they can create systems like driverless cars which are able to see, which are able to speak like Alexa, and unfortunately today there is no effective way of testing these systems because of the complexity of dealing with this. These networks are opaque. Opaque means you cannot explain that this portion of the network with this weight is responsible for this kind of output, saying that it's predicting this. Out of the whole black box, you take it as a black box. So today AI is primarily driven by a black box. So when you have a black box which you cannot explain, you are in an opaque world. There's absolutely no transparency. So how do you evolve testing for such scenarios? Testing in such black box scenarios. The way testing is done typically is, one approach which people say is what is known as metamorphic testing. Metamorphic testing is basically saying that I won't test exact input-output combination. But what I will do is, I will perturb the input. I expect similar perturbation in the output. This is a classic approach, and this is going to be the mainstream of AI testing for tomorrow. Metamorphic testing is being suggested as the next big thing in AI testing. Because we don't have a test oracle, we cannot test completely an input-output combination like the way you can do it in normal functional testing. You have to do it in a roundabout way. How do you do it? By creating a pseudo-oracle. By perturbing input a little bit, seeing what the change in the output is. Is the similar change happening? Example. Suppose you want computing standard deviation for a set of numbers. If I permute the numbers, say 1, 2, 3 becomes 3, 2, 1, does the standard deviation change? No, right? Or the mean change? Now, if your mean changes in your algorithm, that means your metamorphic testing is found some fault in your algorithm. Simple way to understand, right? You perturb your program by permuting it, your property is changing. That means the invariance which is expected with respect to permutation is violated. You're not testing the exact input output, but what you're testing is, if I perturb the input, the behavior has changed. So that is, my friends, the secret of, in fact, this is just about starting to happen that we're talking about. Initial exploration into metamorphic testing as the basis for testing of AI systems. How it's being used? Today, like I said, AI is all about deep learning, right? Deep learning is about a black box of neural network. You give it raw input, raw text, raw image, raw thing, and you get output. So what people are saying is, can I use the concept of metamorphic testing by doing perturbations to basic test cases? Suppose I have this lighting condition like this, right? I slightly change by just switching off one light. Switching off one light there, or just lowering temperature a little bit. So what this does is, it does something close to what you guys know as mutation testing, right? You all know mutation testing, right? So what the current approaches people are suggesting is, can we create models not directly by testing input output, by creating perturbations of the inputs and testing the metamorphic nature of the. So these two are very important: perturbations and metamorphic testing. These are the foundations of future of AI testing. Going further, there is one other important element which I wanted to show you. Can you provide some input guidance on what part of your input is responsible for your decision? Say, for example, I have given a set of input images of cats and dogs, and I have asked to identify which part is responsible for saying that it is a cat, it's a dog. So this is a new kind of testing which is emerging, which is called testing for explainability, which says that, can I perturb the images around and find out which parts of my image is responsible for my classifying it as a cat or a dog, or classifying it as a red traffic signal or a yellow traffic signal. And again, this is based on the same idea, that we don't test exact input output, we test on perturbing the system around with minor mutations. So in AI, we're going to see more and more requirements for perturbation-based testing, and last but not the least, let me tell you, this is a very important part. With slight variation in images, you can change the class. And imagine what can happen from an attacker perspective. With slight modification of images, they can cause attacks to image classifiers, traffic signal classifier is an AI system out there, a cancer classifier, that imagine somebody who is very good at adversarial attacks. They just change slight bits and they cause a non-cancer to be treated as cancer and cancer to be treated as non-cancer. Imagine how lethal it is. So today, what's the solution for it? Solution for it is, can you put some of these adversarial things in your input set itself for testing, which you know are potentially attack scenarios. So that's the only way. So this is yet another dimension of AI testing which needs to be taken into account for future, which is testing for adversarial attacks. And last but not the least, I want to talk about ethics. I'll go with examples, right? Skype, the chatbot example, HR bot example. How do you take care of such accidents from being prevented? It can only be done by testing being done before the release for such bias conditions. You input the conditions which are reflecting bias and see if your system is sensitive to this bias and you react to this. So all I'm saying is, today the challenges in AI world are inadequate testing. And in addition to inadequate testing, lack of a test oracle is a big challenge. So how do you overcome it? Two broad approaches, metamorphic testing and perturbations. Additional challenges, we have to work with testing for explainability, we have to work with testing for ethics, we have to also work with testing for functional completeness by looking at not input-output mapping, but by perturbation of the inputs. So today, there is huge amount of opportunities for all of the testers in the AI field. You take up any of these as options, like adversarial attack testing, or explainability testing, or ethics testing, or testing for metamorphic testing relation between AI input outputs, or testing for perturbations. All of these are things which are not yet completely mainstream in the field, and we hope that in the coming few years, as AI systems become more mainstream, these practices become the norm rather than the exception. Today, unfortunately, many of these have not been followed in all of these systems which have been pulled down. And we're just starting to see the emergence of these practices. But before that, I want to tell you, many of the use cases of AI are still not ready enough to be automated. So manual testing is the only way, especially in case of complex inputs like speech or image or video. So there's a huge way to go where we will see AI testing take shape. But good thing is the realization has come that there is a need for testing as a discipline in the context of AI systems. But people are gung-ho about the algorithms, but algorithms are meaningless if you cannot completely ensure and certify that your system is completely tested before it's unleashed onto the people. Because as we see more mission critical applications going to AI, we need more and more certification that it will be thorough testing for explainability, for bias, for corner cases, for all kinds of extreme inputs. So with that, I stop here.